Measuring light is really easy. There are many sensors capable of detecting or measuring light, but the photoresistor is one of the easiest to use. A photoresistor is simply a resistor in which the resistance changes in accordance to its exposure to light. You can find these devices on eBay for less than $3 for a pack of 10. Think about what you can do with a device that can detect light. Of course, your gadget will be able to know if it's day or night, or if the lights are on. So you could build a gadget that turns on a small light at the entrance of your home when it darkens, so you don't have to walk in the dark. You could also use a photosensitive device to allow two gadgets to communicate with light. This is the principle behind the typical television remote control, where the remote control and the television communicate using infrared light. You could also build a simple robot that follows a bright or dark line on the floor. Can you think of anything else you could do with a light sensor? We'll now create a circuit that contains a photoresistor, and we'll use an Arduino sketch to take light intensity readings from it. Look at the circuit in this image and try to copy it. Here are a few things to be extra careful about. Counting from the right, the photoresistor is connected to a socket in column 1. Its second leg is connected to a socket in column 4. We use a 220 ohm resistor or close, the exact rating is not important in this exercise, in series with the photoresistor in order to create a voltage divider. More about this in a minute. Connect the resistor's second leg to a socket in column 8. Connect the black jumper wire to the ground socket on the Arduino and the red to 5 volts. Even if you switch these connections, the circuit will still work because we are not using any polarized components. Lastly, connect the green jumper wire from a socket in column 4 to A0, which is the Arduino analog port 0. Notice how you connected the green cable in column 4, where the resistor and the photoresistor meet. This type of wiring is called a voltage divider or impedance divider. Its purpose is to create an output voltage that is a fraction of the input voltage to the divider. Look at the diagram in this slide. Vin is represented by the red jumper wire in our Arduino diagram. The earth symbol is represented by the black jumper wire. The Vout is represented by the green jumper wire. Vout depends on the impedance resistance of Z1 and Z2, which in the case of our Arduino circuit are the resistor and photoresistor. Since the resistor's resistance is fixed and the resistance of the photoresistor varies depending on the ambient light situation, Vout will also vary. By taking a measurement of Vout, we gain information about the light intensity in our lab. The higher measurement in socket A0, the more intense the light is. The closer to 0 it gets, the darker our lab is. So this is the photoresistor. I'm going to assemble it as a voltage divider. Resistance of a resistor, a normal resistor. So we'll put these two in series. This is a 1000 ohm, 1 kilo ohm resistor. Measurement is going to come out of the green wire, so I'm going to put it in the middle. The two legs are meeting. This goes to analog 0. Doesn't matter how I assemble the other two will connect. I'm just going to put the green one, the red one, high voltage to 5 volts, and the black one to ground. Let's connect. And upload the sketch. Check the monitor. Okay, I can put my finger over the sensor. You can see that the output changes. On the SS slide, the value goes up because of the way that I have connected the divider, the voltage divider. And when the finger goes off the sensor, the voltage or the reading goes down. Here's our program for this exercise. Much of the sketch should be familiar to you now. There's setup, loop and delay, which we have seen before. There's a couple of new things here. First, look at the setup function. There's this statement in it. Serial begin 9600. This creates a serial connection with the Arduino. The Arduino can use this connection to send text output to our terminal. This way the Arduino can talk to us. This terminal can be opened by clicking on Tools and then Serial Monitor. It looks like this. We will be printing the light intensity value to the serial monitor. Next, have a look at the loop function. We use the analog read A0 function to get a reading from socket A0, which means analog 0, and store it to the local integer variable sensor value. Easy, right? We now have a value captured from the photoresistor's voltage divider circuit. Let's print it to the monitor so we can actually see it. Also easy, just do serial.println within parentheses sensor value, the name of the variable we created earlier. This statement says, go to the serial port, print line with content sensor value. The ln part of println function means that this particular function will create a new line after it prints out the text that is contained within the parentheses. You could use just serial.print parentheses sensor value, but then the output would not be in different lines. It will all be stuck in the same line. The actual values that my program prints versus what your program will print will vary because of the differences in the components you used in your circuit compared to mine. And of course, the lighting conditions in our two labs are probably different. But as long as you see similar values above 0 and below 1024, then it worked. That was easy, right? Please try out the questions attached to this lecture before moving on to the next lecture, where we'll be learning about measuring temperature and humidity.